The technology to prevent it existed, tested, proven, even demonstrated by the railroads themselves. Electronically controlled. Pneumatic brakes could cut stopping distance by up to 60%. Engineers called it the most remarkable advancement they'd ever seen. The industry knew, regulators knew, and over a decade, every effort to require it was quietly dismantled. To understand why, you have to go back to 1869. In 1869, George Westinghouse's air brake system revolutionized rail safety by replacing hand brakes with a fail-safe design. The principle was simple. A single brake pipe ran the length of the train, charged with compressed air. When the engineer reduced pressure in the pipe, each car's triple valve sensed the drop and applied its own brakes. This system worked reliably for short trains, but as freight consists grew longer, stretching to 150 cars or more, the limits of the design became clear. The fundamental flaw lies in how the braking command travels. In a conventional pneumatic system, the reduction in air pressure moves as a wave through the brake pipe at about 340 meters per second, or roughly the speed of sound in air. But that wave must traverse over a mile of interconnected cars. On a modern 150-car freight train, the pressure front can take 3 to 4 seconds to reach the last car. During those crucial seconds, the lead cars are already slowing while the rear continues at full speed, creating a surge of compressive force through the train's length. This sequential lag is not just a technical detail, it is a physical limitation that shapes how forces build up inside the train. The head of the train begins to decelerate, while the rear pushes forward, compressing the middle and increasing the risk of derailment, especially on curves or uneven track. Engineers have documented these risks since the late 19th century, noting that the lag grows with every additional car. The longer the train, the greater the delay, and the higher the chance that uneven braking will overload couplers or cause cars to buckle. Attempts to eliminate this lag by increasing pipe diameter or pump power have failed, as the system's passive nature cannot overcome the basic physics at play. The result is a built-in delay that, on the largest trains, leaves the rear cars unbraked for several seconds, long enough to turn a routine emergency stop into a dangerous chain reaction. This propagation delay remains the central technical reason why the Westinghouse system, once a breakthrough, now poses a safety risk for modern freight operations. Electronically controlled pneumatic brakes, ECP brakes, were not an untested theory or a distant promise. By the early 2000s, engineers had already proven that a digital train line could trigger every brake valve on a mile-long freight consist at the same instant. Unlike the old pneumatic wave, which staggered its way from car to car, the electronic signal from ECP traveled at nearly the speed of light, eliminating the lag that plagued the Westinghouse system. Federal Railroad Administration, FRA, tests documented that ECP-equipped trains could reduce stopping distances by up to 60%, depending on train length and load. In controlled trials, the time for the last car to receive the brake command dropped from several seconds to less than 0.2 of a second. Norfolk Southern, one of the largest U.S. freight carriers, showcased the technology in 2007 with a 2,000-car train running fully on ECP. The company's own investor presentation called it railroad history, and their internal analysis reported a 28% reduction in stopping distance, along with a 90% decrease in variation between cars. The message to shareholders was clear. ECP was not just feasible, but a competitive bragging point. John Risch, a senior engineer and later a union leader, described ECP as the most remarkable advancement in his 3-decade career. He testified that eliminating the lag was not a theoretical improvement, but a direct fix for the forces that cause trains to buckle or derail. Stephen Dittmeyer, The FRA safety director added that ECP provides a deterministic, repeatable brake event that dramatically lowers derailment risk on high-speed, high-mass trains. With the technology proven, the question shifted from whether ECP could work to why it was not being adopted everywhere. The technical solution existed. The benefits were documented. The only barrier was institutional will. In September 2014, the Department of Transportation introduced a draft rule, PHMSA 2014-002, that would require hazardous material trains to be equipped with electronically controlled pneumatic brakes, known as ECP brakes. The proposal landed in a regulatory docket, opening a window for public comment and industry response. Within weeks, the freight rail lobby mobilized at an unprecedented scale. Norfolk Southern and other major carriers registered 47 federal lobbyists in 2015, each named in quarterly LD2 filings. These lobbyists, many of them former congressional staffers, focused their efforts on Capitol Hill, targeting committees overseeing transportation safety and appropriations. The lobbying campaign did not stop at direct advocacy. Industry groups commissioned outside engineering studies, launched an ad campaign under the banner Safe Brakes, Safe Trains, and coordinated messaging through the Association of American Railroads. Senator John Thune, chair of the Senate Commerce Committee, introduced an amendment calling for additional studies before any brake mandate could proceed. The amendment did not pass, but its language, questioning the cost-benefit analysis and urging delay, was folded into later oversight provisions. While the regulatory debate played out, railroads directed their capital elsewhere. SEC filings reveal that between 2011 and 2021, the 7 largest freight carriers spent $191 billion on stock buybacks and dividends, compared to $138 billion on all capital investments, including safety upgrades. The gap between shareholder returns and investment in safer equipment became a matter of public record, even as the industry argued that the cost of ECP retrofits was prohibitive. The proposal, once seen as a step toward modernizing freight safety, became mired in a contest of influence and financial priorities. Norfolk Southern and the Association of American Railroads responded to the proposed electronically controlled pneumatic brake mandate with a unified message. In congressional hearings and public statements, company officials argued that existing pneumatic brakes already met federal safety standards, pointing to a long track record of compliance. A Norfolk Southern spokesperson said, "Our current brake systems are proven, reliable, and safe for operations as regulated by the Federal Railroad Administration." Industry representatives repeatedly highlighted the financial burden of a nationwide retrofit. The Association of American Railroads estimated the cost of electronically controlled pneumatic compliance at over $3 billion, emphasizing that this would divert capital from other safety projects and infrastructure improvements. In a formal comment to the Department of Transportation, the Association of American Railroads President Edward Hamburger wrote, "Mandating electronically controlled pneumatic brakes would impose massive costs on railroads and their customers, with little demonstrated benefit over current technology." Public affairs campaigns reinforced these points, with ads and press releases warning of increased shipping costs and operational disruptions. Company testimony before Congress stressed that the rule would force railroads to prematurely retire thousands of cars and locomotives, impacting jobs and supply chains. The message was clear. The industry viewed the mandate as an expensive solution to a problem they believed was already managed by existing systems. On September 25, 2018, the Department of Transportation finalized the repeal of the electronically controlled pneumatic brake requirement for high-hazard flammable trains. The official Federal Register entry cited the Government Accountability Office's earlier critique, which had challenged the projected benefits of electronically controlled pneumatic brakes and questioned the supporting accident data. The agency's regulatory impact analysis, used to justify the repeal, omitted $117 million in future derailment damages, a gap first uncovered by the Associated Press and later confirmed in a Government Accountability Office review. That omission meant the calculated costs of upgrading to electronically controlled pneumatic brakes appeared to outweigh the safety benefits, even though the underlying data was incomplete. The repeal text argued that existing pneumatic brakes were sufficient for safe operation, echoing the language used by industry representatives throughout the public comment process. No new federal rule has reinstated the electronically controlled pneumatic mandate since then. In 2025, the Federal Railroad Administration issued an administrative update, stating that no additional safety data justified a return to the previous rule, and that the agency would focus on incremental improvements instead. The Biden administration maintained this position, with the Federal Railroad Administration notice confirming that a federal electronically controlled pneumatic requirement would not be reinstated. As a result, the regulatory landscape left American freight trains operating with the same fundamental brake technology introduced in the 19th century. The institutional decision to withdraw the electronically controlled pneumatic mandate, based on a cost-benefit analysis that undercounted the true risks, created a void, one in which a known hazard remained unaddressed and no further federal action was taken to close it. 20 miles before the derailment in East Palestine, a wayside detector flagged a dangerously hot bearing, but the alarm reached a crew stretched thin by recent staffing cuts. The train, carrying 11 cars of hazardous chemicals, could not stop in time. Its conventional air brakes applied too slowly to prevent disaster. In the aftermath, over 1 million pounds of dioxins entered the environment through a controlled burn. The economic toll soared past $1.1 billion. For residents, the cost was measured in fear, disrupted lives, and unanswered health concerns. The technical flaw became human tragedy, magnified by decisions to reduce detector staffing and delay safer braking systems. The pattern of disaster linked to brake failure is not new, nor is it uniquely American. In 1917, a troop train lost control on the steep descent into Saint-Michel-de-Maurienne, France. Overloaded cars and sequential air brake lag contributed to nearly 800 deaths. That same year in Syria, Romania, another overloaded train derailed on a grade, killing more than 600. Nearly a century later, the Lac-Mégantic oil train explosion in Canada left 47 dead after insufficient braking on a hazardous consist. In each case, official investigations identified the same technical flaw: brakes that could not apply force simultaneously throughout the train. The National Transportation Safety Board has repeatedly called for electronically controlled pneumatic brakes, known as ECP brakes, on all freight trains, warning that conventional systems leave a dangerous gap between risk and response. Yet the recommendations have remained just that, advisory, not mandatory, while the cycle of preventable catastrophe continues. Today, U.S. freight trains still rely on technology first deployed in 1869, despite engineers calling electronically controlled pneumatic brakes the most remarkable advancement in a century. Each regulatory delay means the next derailment isn't unpredictable, it's inevitable. The cost of inaction is measured in lives, not just in balance sheets.